Hello, everybody. So I'm Mike Vidomsky. I am coming over from the States here at the Euro Summit. Pretty excited to be here. So I just want to clarify a bit that I'm going to talk about and tell the story about how we at PetSmart basically did some really fast implementation of AI trying to automate loss prevention. And I say fast because we need to do it quickly because we're not really a research house. We don't do a lot of deep learning research. We just need to get fast business results. So hopefully you can learn a bit about implementing some deep learning based algorithms at your retailer if you're a retailer, but in a way that doesn't require you to spend a lot of time doing the actual fundamental research and just trying to get results quickly. So who are we? We are a pet specialty retailer, which means we sell basically dog food. My kids make fun of me. They say, first, I'm not a real doctor because I have a PhD and I can't help them when they break their bones. So that hurts. And then when their friends ask them where their dad works, they say, oh, he sells dog food. Okay. Thanks. Appreciate that, guys. But that's fine. Both are true. I'm a doctor, not a real doctor, and I do sell dog food and a lot of other things too. So our team is the Advanced Analytics Group. And it's funny, PetSmart is, and I imagine like a lot of companies, it's a big company and it does things in an old way. And our group, the Advanced Analytics Group, was formed to try and take pretty much what was let's say 1980s, 1990s approach to analytics and try and modernize it a bit. A lot of the work that was done, was basically some old Netezza databases, which when they were first stood up was fine, but it was really basic BI. Nothing was really predictive. It was all just like, here's what happened. And so they formed our group, and it's myself, another senior data scientist. We have another data scientist, and then an advanced BI guy, as well as our boss, who's a senior director and who's really fantastic interacting with the business and trying to make sure that we understand the business problems, and we translate those into actual machine learning or other advanced analytics problems, solve what they need, and then interpret it and productionize it so that the rest of the company can actually benefit from it. So it's very much a practical group. We try to improve the business performance using machine learning and AI, and it's been a lot of fun doing that. So that's a bit about who we are. So the use case is we are a retailer, which means we sell stuff, and we have services that we sell as well. And so when you sell stuff, people try and steal stuff, and they try and do other bad things to that stuff. So loss prevention is the use case that we're going to be talking about today. And loss prevention can involve a lot of different things. There's theft, which I mentioned. There's fraud. And then there's also, it's funny, one of the projects I worked on before I was at PetSmart was a large East Coast city in America. Anytime somebody tripped on the sidewalk, not anytime, but many times, the city was liable for that. And so they would get claims. Basically, they would get sued, which is really ridiculous because cracks happen. And so a similar thing happens to retailers, right? They're responsible for the property they're on. So there are all sorts of problems that can happen where customers might get hurt or some other incident might happen at a store. And a store leader has to write up a report about what happened, right? So, hey, this thing happened. And they write up a report and it goes into a case management system. Other things happen. Vandalism happens. Waste happens. You wouldn't believe how much can be wasted by not moving old product to the front. So these all seem like really benign, boring problems. But when you have 1,600 stores, it adds up, right? All that adds up to a lot of money. And just like we like to scale our analyses, right? Problems scale when you have lots of stores. So little itty-bitty tweaks in the wrong direction can really harm and cause a lot of issues as far as loss goes. But when you address those, it also scales the other direction and is helpful. So like I said, store leaders write up these reports and say, hey, this thing happened. And then that goes into a case management system. And what happens is there are these investigators that they have to read these reports. And the thing is, most of these reports are actually not a big deal at all. They're low priority. But the job of the investigators is to read them and then actually label them as high severity, medium severity, or low severity. And the high and mediums basically means that we've done something wrong. We didn't follow policy. There's something about what happened that was our fault, and we need to make sure we make it right really, really fast. And then the thing is that most of these reports are actually low priority. Most of the time, it's not important. It's not really a big deal. And so it'd be nice if these investigators, and they're called investigators, could just investigate. But they can't because they have to basically read through every single report. And so our CFO actually came to our group and said, hey, we've got this really, basically, we're going to have to hire some more people to do this thing, which we think you guys can help us with. And we don't think we should have to hire 3 more full-time people, which is like $300,000 or something a year. Can you automate this so that we can help our investigators actually investigate and not have to go and hire more and more people to do this thing, which is really a drudgery and should be automatable? And we said, sure, sounds good. We can try and help you with that. But what's implied there is it needs to be near human performance, right? They need to actually trust the results of the classifier. And so we said, all right, that's great. But a little bit about the data to understand kind of the problem at hand is we had about 13 years of historical data. So these cases where these store leaders would go in and they'd write their report. And it was about 500,000 reports. So 1,600 stores over 13 years, 500,000 reports. That sounds about right for what a typical retailer would have to go through, right? This thing, it happens all over the place. It's not these issues and loss prevention is something that happens at any retailer. So it's not unique to PetSmart. What's interesting, though, is it is imbalanced. Just like I said earlier, most of the reports really were low priority, something where the investigator would just read it and then they'd move on. But another thing that's interesting, it is free text, right? So we love our store leaders, but they're very busy and they don't always focus on really great grammar. And so when they write up the reports, the grammar can be non-existent, right? You know, this thing happened, it's really awful, or they'll use abbreviations. So we refer to our customers as pet parents, right? Because we really love pets and we believe pets make our lives happier. And so, you know, the people who own the pets, they're their pet parents. But the thing is, in the reports, it'll show up as like PP, right? Which stands for pet parent, not going to the bathroom, right? But these are little things that are important when you're trying to, yeah, sorry. This is important because when you're trying to build a text classifier, language matters. Spelling is important, grammar is important, and so trying to deal with the non-conventional English, in this case, was something that we needed to deal with. Something else that was interesting is the legacy system that we were trying to get the data from was awful. It looked like it came straight out of Windows 95. The text, like the fields, I'm not kidding, there would be like date fields in the free text. It really is broken for a long time. And so we were dealing with just an awful system. And you'll see how that problem was something, well, first off, I don't think legacy systems are something unique to us either. Legacy systems exist in every company. I'm sure some of you are even dealing with like mainframes and other bizarre things that are just difficult and challenging. And so you have to like help bring it to the 21st century. So that was something else we're trying to overcome. So here's the old workflow. As you can see, we have the store inputs. It goes into this case management system, right? Those are the free text reports. And like I said, most of them, so there's an interesting statistic here. Just going to note this now. This 72% statistic, another number comes up that says 72% as well. It's coincidence that they're the same. I'm just warning you that now when you see it later. Okay, these are actually different things. So there is some logic where some of the cases are automatically said, hey, these need to go to the team of investigators to review, and some of them go elsewhere, just so you know. So most of the cases do get reviewed by this team. Well, that legacy system I talked about that basically is broken, it's so bad that you can't even, there's no prioritization at all, and you have to go through the cases in chronological order. So if there's a stream of maybe 20 low priority cases, the investigators have to read through every single one until they finally get to a case that actually might be important. And this is important because if there's an issue that really needs to get resolved, maybe somebody's hurt, clearly if somebody's hurt, you know, in the field that's being taken care of. But if there's something where we need to react quickly to help make sure that our pet parents, that our customers are happy and are being dealt with in a way that's good and is good customer service, we want to respond to them very quickly because we do care and we want to make sure that they feel that we care. But in this approach, we can't do that, right? We have to kind of wait and either there's a saying, the squeaky wheel gets the grease. We'd rather there not be a squeaky wheel. We'd rather grease the wheel proactively. So the investigations team accesses this case management system, they review it, and then they label it as high, medium, or low. And then the case goes out to the field and is resolved in whatever way is appropriate for the case at hand. So I'm going to skip ahead a little bit. So pretend now that we've got a classifier, and I'll talk about the classifier in a bit. But now we've built a classifier that takes in the text, and then we auto-classify it as either low or high/medium. And so you can see the little trick there. I turned it from a multi-class problem into a binary classification problem. And that's because what really matters is the stores, it's important that we know how well they're doing in terms of resolving loss prevention. And so high or medium is something they're measured by. How many of those cases do they get? And so that's important that as far as us resolving the issue with the store, is it a low or is it a high medium? Because they're actually scored, their performance is scored based on that. And so we're able to use a binary classification, which simplifies the problem, but also represents what matters as far as our store's performance. So then you'll notice what happens is we have the model, and the text is run through the model, and out comes a probability of it being high or medium. And then that's actually put into a dashboard. And unfortunately, I couldn't get permission to show the dashboard itself. One of those weird, I don't know why, it's just a dashboard. Can't I just show these nice people a dashboard? But no, I couldn't. So just pretend now you see a dashboard where the column of the probabilities is sorted right in descending order, right? So you've got the highest probability cases up top, and then goes on down to the lowest probability. That's useful because now all of a sudden, our investigators can at least look up the cases that are most likely or that have been predicted to most likely be high or medium first. They still have to go to that old legacy system and they actually take the case ID and they put it in and they manually search for it, right? So this is still really ugly and awful, but it's still better than what it was. And then they'll actually read it and then they'll assign the probability or assign the actual severity. And it goes to the field and is resolved appropriately. Okay, so that's great. But what we'd really like, and what I'm going to describe, the model that we built, which I'll describe in a minute, is actually going to enable, is still a future solution. We're thankfully replacing that legacy system with a more up-to-date system where we can actually auto-write the score for the cases. In other words, the model provides a probability of it being high or medium, and then if it's below some threshold, and we haven't picked that threshold yet, but basically if we're really confident that the case is low priority, let's just go ahead and skip the investigators altogether, right? Auto-classify it as being low priority, and then have it just kind of go away and not have the investigators waste their time. So this is that statistic I was talking about earlier. 72% workload reduction. That's the maximum, basically the ratio, the proportion of low to high priorities is there's 72% that are typically low. That obviously fluctuates a bit over time, but that's about the moving average. And so if we can get rid of all the low priority cases automatically, basically what you've done is you've taken an 8-hour workday, where in 6 hours, 6-ish hours, we're spent reading pointless cases, and you've removed that from these poor people's lives. So an investigator can now actually investigate. So you freed up 6 hours to go and really understand what's happening, to interact with customers, or to help the field understand how to interact with customers. All right, so this is sort of where the magic of automation comes in, is you've now freed up so much time so that your team can go and do their jobs in a real way, as opposed to wasting it going through and reading useless cases. And so this is fantastic. And so they'll only investigate those higher or those medium priority cases. Okay, so this is only possible, though, if you have a model that does really well and is trustworthy enough to actually auto-classify low priority cases. So how did we get to that? Well, we started early on using the classics, right? We did some TF-IDF feature creation, some word counts, also some in-gram TF-IDF. So basically, we made a bunch of features using some very traditional natural language processing techniques. And then we use those features and we threw them in some of the classic algorithms that we are also used to, right? So logistic regression, random forest. We tried some XGBoost, and notice there I kind of slipped in a little multi-classifier. What's interesting though is I love random forests. They're just, I don't know, there's something beautiful about them. And for this problem, it just didn't work well at all. I don't know why. Logistic regression was pretty decent, right? 81% AUC. That's not a bad performing classifier, but it's not really good enough to automate the classification of these cases. It just wasn't quite there. And so while the performance was fine, it wasn't good enough for what we needed. And so we said, okay, great. We need to get a result. We need to get it quickly. And it needs to be good enough that we can trust it so that we can auto-classify these things. Because, there's some realistic things here. I don't know about you, but at my company, we get an annual bonus, which is nice. And that bonus is based off of different metrics, things that we do to perform. And our store leaders, their bonus is also based on different things. And one of those things includes, basically, how many things happen at your store? Is loss prevention a problem for you? And we want to make sure that if something is auto-classified as being a problem, that these store leaders aren't getting dinged, right? Their bonuses basically aren't getting dinged inappropriately. So we want to make sure that it's right. Okay, so that was early modeling attempts. Now, when this was happening, this was back in basically August to October of 2018, which in like the AI world is eons ago, right? It was a long, long time ago. I mean, really a long, long time ago. So like already this is not the most up to date. This isn't the most like cutting edge stuff. But at the time, it was pretty great. So there's these guys, Jeremy Howard and Sebastian Reuter. Jeremy Howard, he's out of UCSF. And he had basically started to implement FastAI. Pretty much was one of the earliest attempts of successfully using the concept of transfer learning in NLP. So what that was is something that works really well in image classification and recognition is essentially when you have a deep neural net, the lower layers tend to represent more fundamental features of an object, say an image. In this case, let's think of an image, right? So like edges, maybe shadows, those kinds of basic things that are fundamental to anything you're trying to actually represent and model. So now let's bring that over to language. And you can think of the lower layers as being essentially the foundational things of language, like grammar. Verbs, right, represent action. Nouns represent objects, that kind of thing, and the relationship between those, right? Verbs act on nouns, or nouns perform verbs. And so he really took advantage of, and he kind of thought about it in a clever, very practical way. So how can we take advantage of transfer learning in natural language processing, much like that was done in the sort of imagery world? And so what he did was he worked through a lot of fine-tuning techniques that tried to do the same thing in NLP. And they were successful. Really, I say Jeremy really did most of the work here. What Sebastian did was helped Jeremy put it into a paper and publish it, and also, and if he's here, I'm sorry, but he basically said, hey, let's make this rigorous. Let's actually study it, and let's show that it works over a lot of different kinds of problems, and then do some performance testing. So. That's sort of a really quick intro to how FastAI began. And what it is, it's a 3-layer LSTM, right? So the number of units isn't really that important. But they didn't actually come up with the base model, which this is why, for me, as a data scientist at a retailer, was so fantastic. I didn't need to go out and figure out what's the best structure, right? What kind of model should I develop? What they did was they took a language model. It wasn't even their language model. They took Stephen Merity's language model, which he's a guy from Salesforce. They do a bunch of research there. And they took a language, and what the language model does is its job is to predict the next word. That's really what it is. You feed it a sequence of words, it predicts the next word. And then, of course, you put in that word, and it predicts the next word. And you can generate text that way, and eventually it makes no sense, at least these earlier ones. Though some later ones are creepy. I don't know if you've heard of like the GPT-2 stuff, but it is really scary. But that's not this. This is just, your good classic LSTM. So it wasn't even their language model. And what they do is they take a language model that was based off of Wikipedia text, a pretty big one, and they say, okay, great. We're going to take that language model, which has figured out some structure, right? Basically, there's some relationships between words and grammar, so the nouns and the verbs, etc. And we're going to use that, and we're going to fine-tune it first on our corpus, right? So our text. In other words, Wikipedia text is different from whatever text that they're looking at. So there's some interesting things that maybe aren't captured in the Wikipedia text that are in your language. So for us, we have these cases or these reports that would get written in by the store leaders. So for example, pet parent abbreviations, PP, or other really weird things that come in, spelling that's awful, perhaps really bad grammar, right? Those sort of nuances, what you do is you take the base language model and you fine-tune it on your text. And then, after that, you remove the head, basically the part that predicts the next word, and you replace it with a classifier. And so now you have a classifier that in the beginning, the weights it's pre-weighted with the structure of the language that's actually being used for the input text to classify it. So already it has naturally in there an understanding of the language that's being fed into it, but it's being repurposed towards classification. And so this is a beautiful thing. Transfer learning is really fantastic. But the way that they actually go through and suggest retraining and fine-tuning the deep learning model is super clever, right? And so remember I talked about earlier, the lower layer models are more fundamental features, right? They represent more fundamental things. So when you're fine-tuning, say, the language model to your text, you don't necessarily want to completely retune or fine-tune the entire model all at once, right? You want to fine-tune maybe the higher layers because that's the stuff that's more specialized towards your actual use case. So for example, you could think about how when you create there's the bias variance trade-off when you build a model, right? If it's overspecified to your training data, then when it comes across test data, it won't really perform as well. Same-ish kind of thing, right? The higher layers, you don't want to have them overly tuned towards a specific kind of data. And so you fine-tune those first, or you unfreeze those, run it through one iteration, and you fine-tune it towards your data. And then you unfreeze gradually, and eventually you do unfreeze it all the way as you build your classifier, but you don't want to do it too soon. So that was one of the things that they did. And a couple other things is basically there's, when you build a deep learning model, right, there's how fast it learns. And so they came up with a really clever scheme for having an adaptive learning rate. And they do a few other, you could call them hacks, but the way that they come about them and think about them and the way they develop them is really understanding what is it they're trying to solve and what is the model actually built to do, and then picking the parameter tuning such that it matches what it is you're trying to solve. So what's fantastic about this approach, FastAI's approach, is because it's built off of a Wikipedia language model. If there's a Wikipedia in a language, you can take that language, build your own model, and then run with it. You don't have to go and create an entirely new model. You don't have to go and create a whole new structure. The architecture is already there. You can take a language model, and they've done this, right? They've done this with Chinese characters, they've done this with other languages, and very successfully built and done essentially the same sort of problem in other languages. So they've given companies like mine, where we're not a fundamental research group, right? We aren't Salesforce, we aren't DeepMind or any of the others. What we want to do is we want to come up with good, quick business solutions that are state of the art or close to it, or they were at least a year ago, and then are useful and practical and can be put into production quickly, right? So that we can actually start seeing business value from these things. Okay, so here's how it all started, though. Now, when I showed this deck to a few friends, they saw my little, I don't know if there's a little laser on it. They saw this right here. Who knows what this is? Don't say it, just raise your hand. Who knows what this is? Okay. All right, is it a trash can? If you think it's a trash can, keep your hand raised. Yeah. So did all my friends. Okay, it's not. It is a Mac Pro, right? And this is where it all began for me. Like I said, my company was kind of coming out of the, I don't know, Middle Ages of analytics. And so when we first started, this is what we had to deal with. I was just happy to have a Mac Pro, right? I mean, it had plenty of RAM, really great. Big deal, though, especially in deep learning, is no NVIDIA GPUs, which is a real problem because you just can't without GPUs. It just takes forever. For instance, so I set it up in a Jupyter notebook, and FastAI is built off of PyTorch, which takes advantage of all the CUDA optimizations. And so, unfortunately, because there's no GPU, it took like 7 days to even get through, I think, one iteration of the language model. So as you can see, it wasn't going to work. It was really kind of ridiculous. And I'm highlighting this because I want you to feel my pain, right? I mean, I started this on a weekend, and I was like, okay, sweet. I know this is going to take a while, but Friday evening, let me start this baby off. I'll come back in on Monday, and we'll see how progress goes. And I come in, and it's like, I don't know, 3% done. I'm like, all right, this is going to be really good. And so, 7 days later, I said, fine, this is ridiculous. And so we knew something needed to be done. So at this point, we had started doing quite a bit of our work on Databricks. We did have it at the time. We are a Databricks shop. But it was still sort of early on in our usage of Databricks. And there were a few things that hadn't existed yet in the Databricks world. So they talked about the ML runtimes. That didn't exist right when I started doing this, when the Big Mac came around. But as you see, Providence provided, and all of a sudden, ML Beta 5.0 came out, like right, I'm not even kidding, like the week after that whole Big Mac thing came, the ML Beta came out, which is great because FastAI, built off of PyTorch, had a bunch of dependencies that I just didn't have in the basic Databricks runtime. And so it needs like Python 3.6, which didn't exist in the Databricks runtime before. And so I needed later versions of Python. There was a lot of configuration that needed to happen that wasn't really easy to do previous to these ML betas coming out. Well, the ML beta came out, and all of a sudden, yay, I can actually install FastAI on Databricks. The thing is, though, I still didn't have GPUs. So we use Azure Databricks. And first, I don't remember if it was like me going and talking to somebody at Databricks or Azure or what, but the same week, the GPU version, so GPU hardware showed up. So we had VMs that now had GPUs. So like magically, all within the span of a week, we got everything we wanted. It was great. It's like we got our GPUs, we got our basically a runtime that'll support installing FastAI, and it was all right when we needed it. It was really just kind of like the best week. It's like, thank you. This is fantastic. So Providence provided, and there we were. It did take quite a bit setting it up. So the thing about the ML runtimes is they have everything in there. So they have TensorFlow, they have Keras, PyTorch, but they have it set up so that they work together themselves. But FastAI is sort of, you can think of it as like PyTorch with some really nice wrappers around it, really for groups like mine where we just want to get, we want to build a very good solution very quickly without having to go through all of the sort of fundamental work. But to get that going, you needed to, there's a lot of dependencies you had to get it worked in there. So our data engineering team helped us with that, and we got it set up. So that was really fantastic. So we got it running, and then all of a sudden, I'm going to skip to the bottom of this slide. The language model fine-tuning took 24 hours, which sounds crazy, but when it didn't even finish before, it was honestly going to take probably like a month. Now we're at 24 hours. Like it was like a 20-something speed up, 20 times speed up. We're pretty excited about that. And then the actual classifier fine-tuning also took about 24 hours. So we went from what could have been a month's worth of work to now 2 days for a turnaround on building a model. And not only just a model, but a model that, I mean, has a discrete jump in performance. I mean, really just fantastic performance, going from like an 81% AUC. I'm reporting accuracy here, but it just turns out that the AUC and the accuracy were about the same. The numbers are about the same. Clearly, they represent different metrics, right? They represent different things you're measuring. But we went from what was, not really acceptable to something like, okay, we're starting to get there. Like, this is starting to look pretty good. I can, maybe we could start automating with this. Well, one of the interesting things that FastAI recommends is building a bidirectional model. And really what it is you build a forward language model, right, which predicts the next word moving forward, and you build a classifier on top of that. But then you also do a reverse one. So it's a backwards language model, which predicts the preceding word, and then a classifier on top of that. You score with both models, and then you take the average of the two. And that gives you generally about a 1 percentage point increase in accuracy and or AUC. So, which is nice. And we experienced that same sort of increase in performance. Of course, the trade-off is it now doubles how long it takes. But given that we're now in an environment where we can train a lot more quickly, that was acceptable to us. That was okay. One of the reasons why we're so excited about doing it in Databricks is we could have stood up an Azure VM, but the thing is, in a cost-conscious retailer environment like mine, you have to pay for it always. So once you turn it on, it's on, and you have to pay for it the whole time. And while we aren't penny pinching, that is something you kind of think about. But what's beautiful about Databricks, as you all, if you use Databricks or use that service, is we were able to just turn it on when we needed it and turn it off when we didn't, right? And we could scale the cluster if we needed to, right? So if we figured out, now granted, these kind of models, all the work is done on the driver, right? Because it's deep learning, and so it's not something that, at least the way we've set it up, you can set it up to basically be sharded out, but that's not how we've done it, right? So we just got a big fat driver with like one or two really sort of dinky worker nodes to do some of the ETL before we got it in there. And then just let it run on this big fat GPU on the driver. And then turn it off when we're done. So we have this really huge driver while it's running, and then we just turn it off. So that was really fantastic for us. So the thing is, though, we wanted a little bit more, and this is where we kind of did some experimentation. You remember in one of the keynotes, one of the things about deep learning is, and as you know, the more data, generally the better. Well, with the language model, you can kind of throw any text that you have at it, and you're just modeling the language, so that's okay. So even if you have unlabeled data, you can throw it at the language model and fine-tune it and make it appropriate for that, make it more fine-tuned to your case. However, what we weren't sure is, after working with the business, so this whole time we're kind of interacting with this team of investigators, we talked to them and we realized the team leader over this team of investigators, she was hired like in 2016. And it turns out until she was hired, they weren't really as consistent in how they labeled the data. Oh, crap. All of a sudden, we've got all the data from 2005 to 2016 isn't necessarily labeled properly. And we have no way of knowing, except for actually going through each one, which ones were slightly off. In other words, we now didn't know. We were training our classifier on mislabeled data, but didn't have a nice, efficient way of going back and finding out what it was, except for actually going through and doing that. So we're like, oh, great. So what we didn't know was this. Is it better to train on all the data, even though we know some is mislabeled, or is it better to say, look, we know it's pretty consistent from 2016 on. Let's just retrain the classifier on that data, use all the data for the language model, but 2016 on for the classifier. What's going to be better? We really didn't know. It seemed logical that it would work out that way, but we just had no idea. And so this was kind of a fun experiment for us. And it turns out, as you can already see the punchline, it really was much better. As soon as it got, because we didn't know the proportion, we didn't know what percentage of the prior to 2016 data was bad. There's really no way for us to know a priori to that. So it did a lot better. So we built the bidirectional model on 2016 plus data, and it turns out we got a huge jump, huge to me. I mean, going from 93% accuracy to 96% accuracy, basically by retraining it, that's fantastic. So that was a cool finding for us. All of a sudden, we're feeling really great about things. Our business partners are feeling good about it, and they're like, okay, great. this is something we can trust. Of course, we don't have the new system set up yet, so it's sort of like, awesome, great, yay, we're all excited. And then we're waiting for the new system to come in so we can actually write back and auto-label. So we've done our part, right? The AI is there, everything's sort of there and waiting. We just need to be able to actually write back to the database so that the investigators can skip the low priority data. So that was really exciting for us. Right now in production, I'm kind of proud of the fact, I don't know if I should be, but we have what is an alpha version software, right? FastAI version 0.7.0, where they have explicitly stated this is alpha in production at PetSmart. I don't know, maybe that's insane, but we made it work, right? And it's working. We have hourly jobs. It's not streaming yet. There's tons of things that we could do better. We know, like, why isn't this is a natural use case for streaming, right? Store reports come in, but we didn't set it up that way, and that's okay. So what we do is we score hourly. We retrain the actual classifier monthly. So we just have a job that what it does is we take the last month's data, right? It gets added, and then we retrain the classifier on all the data up until, well, from 2016 up till the last month, right? Because we do know more data is better, but we want it to be correctly labeled data. And then moving it from dev to production was pretty straightforward. Essentially, we just cloned the notebooks. It is in notebooks. Cloned the notebooks and then scheduled the job, and it's been running pretty well. And so that made making it production pretty simple for us. Just some final thoughts. It did take some work to get it up and running, right? Like I said, it's an alpha version, so there were some interesting things to making sure the dependencies were done right. And so we didn't have containers set up, so they're still working on having containers in Databricks. And so it's not in a container yet, but at some point we will make it container. So all we have to do is just bloop, there it is. Our runtime is like it should be. But right now the setup of the cluster takes a bit of time because it has to download all the packages and the dependencies have to be worked out and stuff. But the performance we're really pleased with. It worked out really great. FastAI, for us as a retailer, to get from what was not acceptable to pretty spectacular performance was wonderful. We didn't have to reinvent anything. We didn't have to do any fundamental research. We could take what was then cutting edge and apply it practically, get some business value out of it. We're able to save hundreds of thousands of dollars a year. And for us, Azure Databricks was really the most cost effective. We can turn it off when we don't need it. We turn it on when we do. And we're able to iterate and do some experimentation. And this has sort of been the foundation for a lot of the work that we're doing moving forward. So it's been really fantastic. I know I kind of went through that quickly. Thank you all for being here. And we've got about 2 minutes for some questions. Yes, please.
Thanks, Mike. I'm also a data scientist which work on the NLP. And one of our cases is that we are also doing the multi-topic classification on the multiple topic. But what we are using is the birds on the PyTorch framework, also in Databricks. So I'm thinking that whether I should still use the FastAI or I just use the birds plus the PyTorch is enough.
Great. So okay. So her question is basically, Mike, why aren't you using the most modern NLP models? Great question. We could. Basically, it boils down to the work to get this. We can't justify it to our business leaders. This is already working. It's at an acceptable. It's like the 80-20 solution. Has everybody heard the 80-20? Just give me the 80% solution. This is the 80% solution. It works well enough. Believe me, I would love to. And if we have to do this again, we will totally use the BERT model. Absolutely. Great point. This is the 80% solution. Yes, please. You bet. Yeah. So the question was, how do you retrain the language model? So you download the original like Wikipedia language model, and then what you do is you unfreeze, I believe, the top layer for one iteration. So then you feed your text in, right? And so you're unfreezing just, I think, the top layer at first, feed in your text so it updates those weights, and then you unfreeze the top 2 layers with your text, it updates those weights, and then you unfreeze all of it. And then I think it was, 11 iterations about-ish, where you unfreeze all of the layers and then iterate through your data 11 times. And that's the language model. And that takes about 24 hours. It's the 11 loops that does it. And it does it, chunk-wise. Does that make sense? Okay.
Well,
10 seconds.
Well, we're arriving to the end for this session, but you can still ask questions, Mike, at the room. I mean, feel free, I guess, to ask you. One thing is, don't forget to rate the session. If you like it, just say it in the app. If you use the Spark Summit app, just say it was interesting and we liked it. And yeah, well, we get ready for the next session. Yeah.
Thank you.
Thanks, Mike. It was really great. Thanks.